Once again, warm up 100, shouldn't take you long. Sketch a box plot and a bell curve, 2, 15, 23, 30, 47, and 23. See how long, it shouldn't take you long, right? We got this. All right, everyone there, what you got, and we'll get the show on the road. Today's session is a little short, but very powerful because we're wrapping up everything we've been seeing up to right now. So let's start with our box plot. Show your neighbor what you got for those values, please, for your box plot. All right. Let's see, help us out. Let's get started with Q1, Q2, and Q3. Chelsea, what you get? What is it? 15 for Q1, Q2, 23. Let's go. And Q3, what is it? 30. Hands if you got something like that. That's about right. And of course the min is 2 and the max is 47. Okay. Go to the bell curve. And once again, the process, by now we are experts. We need to order this from least to greatest or in ascending order and so on and so forth. We need a mean. Pass on one, Chelsea. What is it? I'm sorry, I couldn't hear with the AC. Okay. $23 what? 0.5? 23? 23.3. Okay. All right, hands if you got that. Looks about right. And we need a standard deviation up and a standard deviation down. Show your neighbor before we pass that to someone. What was our standard deviation? Standard deviation. Standard deviation. All right, pass someone. Mia Victoria. Go. 8.67. Hands if you got something like that. No? We got a disturbance in the force? What? All right, let's see what you get for that, Diego. 32.9. Standard deviation? Huh? Hands if you got 32.9 for standard deviation. Okay. Help him out, Fernando. 13.7. Hands if you got something like that. That's a lot closer. I'm going to go with this one. So 13.7 plus 23.7, that's 47. Yep. 37? Oh, I did that on purpose to see if you were paying attention. Oh, later. Thank you. Okay. 37. And the other N is 9.3. Is that correct? 9.6? What's 23.3 minus 13.7? 9.6? What is it? 9.3? I was right. Let's go. 9.3. All right, and that's our normal range. All right, thank you. Thank you, Lenny. Warm-up number 100, copy the agenda, combining probability and counting rules. Today we're going to do like a combination of everything. I'm going to give you a couple problems. One of them It's going to feel a little bit robust, but doable. And the second one, I'm hoping your noodle is already able to do the computation for that second one. Then we'll get into one last exercise, being our special 100th warm-up day. Let's go. And tonight's home play 4.5 exercises, numbers 1 through 10 odds. So when you get home, go to the end of lesson 4.5, go to the exercises at the end. Just do numbers 1 through 10 odds only. All right. So get a Cornell note ready while we have everyone else send me their warm-up as they finish up. All right. So I can identify and compute basic probability. We've been already through a bunch of stuff. Here goes a reminder where we've been. We talked about probability being the chance of an event occurring. We talked about classical, empirical, and subjective. Now, once more, tell your neighbor the difference between classical, empirical, and subjective to make sure that they remember where we're at with that. Remind your neighbor, please. Yeah, by now we're experts because at the end we even made posters and you guys made videos for all of this. And you made up examples for each of these. So from there we went to classical and empirical with formulas. You guys remember these formulas right here? Yes? Where for the classical is basically just finding the odds. For the empirical we needed frequency because we actually experienced empirical. From there we talked about probability rules, 1, 2, 3, 4, and we went to complementary events at the end. From there we went to addition rules. And what was the key word there for each of these? The word what? Or. That is correct. From there we went to multiplication rules, and what was the key word there? And those were for the word problems that we were given. From there we went to conditional probability, and here it was. And this bar represents what word? Tell your neighbor once more. This bar right here represents what word? Remind your neighbor. What is that word? Mia Victoria. Pass them one. Peyton. This bar represents what word? Given. That is correct. B, given A. Okay. And then from there we went into fundamental counting rules. We had the fundamental and the factorial. From there we went to permutation, which meant that the order mattered. It was a specific order. And from there we went to combination where order did not matter. Okay? So here they are. So today we're going to put all of that together. All of it. And I'm going to focus right now on using the probability of a classical formula combined with these two. But for the sake of just staying focused on one section, I'm going to focus on the classical formula and the combination. So copy these two on your paper at the top so you can have them handy. The classical P of E equals N of E over N of S, and then the combination. We're going to be using those two for this next problem. Okay? Yes, Mrs. Q. Example 2. Write it down, please, so you can have it as a sample. A store has 6 TV graphic magazines and 8 news time magazines on the counter. If 2 customers purchase a magazine, find the probability that one of each magazine was purchased. Copy that. All right, here we go. So, As I mentioned before, we're going to go ahead and combine this all together. So let's write our formula here to get started. P of E equals N of E over N of S. So of course, P of E, this is what they're asking for. Is that correct? So let's start replacing stuff. So P of E, what are they asking for? It says, find the probability that one of each of the magazines was purchased. So one of each. What magazines? What kind of magazines? TV Graphic. And the other one is what? News Time. So then I'm going to write TV and NT for News Time. You're like, oh snap. Oh snap is right. Equal. So we're following this original classic probability formula, but now we're going to have to, if you notice, there's two different magazines, two different scenarios. That means we need to use our combination formula. Let's write it underneath over here to have it handy. This is n factorial over n minus r factorial, r factorial. Okay, so here we go. If we're following this, what did we say n of s was, everyone? Bless you. What is n of s? What is n of s? Peyton, pass someone. Chelsea, n of s stands for what? The total, of course. So how many total magazines do we have, everyone? How many total magazines? 14. And how many are they going to purchase? 2. So how would we write that underneath? 14. What? Combination 2. That is correct. All right. However, at the top is the selected items. So, how many TV Graphic do we have? 6. And how many are they going to purchase out of that? I'm sorry? 1. So how would we write that for TV first? Because that's the first part that we're doing. Tell your neighbor, what would you write here for TV? Chelsea, pass someone. Who? Joseph. 6. That is correct. And since we wrote and, what operation do we write next? Multiplication. That is correct. Ooh-wee. So tell your neighbor what to write next if the next one is NT. What to write next right there. Joseph, pass someone. That is correct. So now that we have our formula to follow, let's write 6C1 here and 8C1 there. And then down here, 14C2. I'll give you a head start. Find me that computation. So like that we can fill in values up here. All right, for the sake of checking your work, look up to the screen. And if you got something like that, that is correct. So basically, all we're doing is combining formulas with formulas, and that is something that is done when it comes down to probability of application to different scenarios. So just keep that in mind. I just wanted to show you this example. All right. So, with that said, look at this next one. And it reads, the California Powerball jackpot, right now, I stopped this morning to get my coffee, and I saw that it was at $645 million. Let me repeat that again. The Powerball is at $645 million. Isn't that crazy? What do you do with $645 million? You're like, I'll go to Johnny's. What's that? All right. Oh, no. No. It says, what are the odds of you winning the jackpot with one ticket? Ooh. Let's say somebody gave you a ticket. Since, you know, some of you are still not 18, doesn't count. However, let's say somebody gave you the ticket and you actually won. Use the formula after getting information from the play slip below. Look at the play slip. Now, for those of you that, do you guys know how to play Powerball? Okay, this is how it's played. For Powerball, they put all the numbers in a little cylinder with air, and all of a sudden they start randomly getting numbers out. So you first need to, look what it says here, select what? Select 5. So first you select 5 numbers. Once you select 5 numbers, look what it says down here. Down here it says select 1. That's why it's called the Powerball. That's the Powerball number. So you first select 5 and then you select 1. Okay, so now that I told you how to play, look at the information that you have here and first gather the information, and then I'm going to ask one of you, which formula shall we use? Which formula shall we use? Talk it over with your neighbor. And let me zoom into the play slip. Let's see. Talk it over with your neighbors. I'll give you some time. Go. Record this. If you were to actually play live, you needed to pick 5 numbers from here. But if you don't want to go through that and you just want the computer to do it automatically, you just select this little square right here that's called QP, Quintanilla. No, just kidding. It's called Quick Pick. The computer does it by itself. It picks 5 numbers. But look at the information for the first 5 and look at the information for the second part. All right? Talk it over to your neighbor, let them know what information you need and what formula are you going to use. What formula are you going to use and what information do you need? There's this and there's this. Huh? I think it's $2, something like that. All right. Let's do the first part. For the selecting the first 5, what formula are you going to use? Who went last? Peyton, pass them on. What? NCR, that is correct. NCR, a combination. Now, why did she choose that? Think about it. We pick one, then another, then another. Does it matter which one's going to come out of the ball? No, it just comes out randomly. So that's why we choose this one. However, tell your neighbor what N stands for and what R stands for. Tell your neighbor what N is and what R is. Pass someone? Adderley? $69. What? Out of what? 5. That is correct. For the first part, we're going to select 5 numbers out of 69. Go ahead, Joseph. So, once again, do that computation and see what number we come up with so far up to right there. So you should have written 69 factorial over 69 minus 5 factorial times 5 factorial, yes? So 69 factorial over 64 factorial, 5 factorial. So 69 we end up with 69 times 68 times 67 times 66 times 65 over 5 times 4 times 3 times 2 times 1. Does everybody know where the 64 factorial went? Yes, right? Okay. All right, who's got a number for me? Fernando, pass someone. Jaden, J. Will, what'd you get? He said Montes? No, he said W. 69 times 68 times 67 times 66 times 65 divided by 5 times 4 times 3 times 2 times 1, and that gives us who's got a number for us already? Diego? 211, 258, and what else? 230. Oh, my bad. So 238, 515. Looks about right, but that's only for the first part of the lotto ticket. Tell your neighbor what we need to do for the last part. What formula would we use for this last part? What formula shall we use, Briseida? We already used combination. Yes, permutation, that is correct. However, for the permutation, what is N and what is R? Tell your neighbor what N is and what R is. What is N and what is R? Pass on one, Briseida. Illy. 26 and 1, yes. 26 factorial over 26 minus 1 factorial is 26 factorial over 25 factorial, which is what? 26, yes. So, now that we have this, and now that we have this, what do we do at the end? Tell your neighbor. Yes, multiply them. So what we got for the combination and what we got for the permutation? Odds. What are the total odds of you winning the lotto? Pass the one, Illy. Who? Princesa. What'd you get? What is it? 3 what? 338. So, for one person to buy a ticket, it's one out of how many? 292,201,338 odds of you winning the lotto. Woo-wee! That's a lot of... That's why it keeps growing on that number, guys. It's really, tough to get that. You know what I'm saying? So, let me send you the screen so you can send me your notes, and then you can go ahead and log out. And for those of you following on YouTube, make sure you get some practice in at the end of the 4-5 section. Have a good one. Enjoy. Bye.